All right, so here's where we are. If I remember correctly, welcome back. If I remember correctly, you selected different masses, and we measure our masses in kilograms. And again, what we're trying to do is we're going to believe that whoever wrote the number of kilograms on there, we're going to believe them. Is that cool?
Yep.
And then what did we measure as a result? The weight in newtons. True? Does that seem vaguely familiar? Okay, and you plotted it, and what did you end up with when you plotted?
Linear.
Definitely linear.
Positive slope.
Linear and positive, I like it. And on Tuesday, we decided, like, for simplicity, because the values were all around this, and we're just trying to, like, understand this, we decided on a slope value. What did we decide on?
10.
Good. 10 what?
Newton per kilogram.
Yepers. Now, that's 10 newtons for how many kilograms?
1.
For every 1 kilogram. So I would like to make sure that you have a good for every statement on your page that goes with this. All right, so take a moment now, check your notebook, make sure you have a good for every statement that goes with this slope. All right? Yes.
Oh, we just are for every statement.
Oh, okay, well just hold on, let's make sure everyone, okay? Want to make sure everyone has a good one.
It's too quiet.
It's too quiet?
You have to ask me my question.
Do you have a question?
She does.
It's not about physics. What if I actually ask the question?
Well, it's not about
Feels pretty good. I mean, when, she's right, when has she asked a question about this?
Lauren, do you have a good for every statement?
I think.
Go for it. Let's just see what it is.
For every 1 kilogram increase in mass, weight increases by 9.987.
Good, and we're going to go with 10. So Lauren is right on the money here. She says, look, for every 1 kilogram increase in the mass, the weight's going to increase by 10 newtons. Does that sound good? What's also nice about this is because your intercept is 0, that means if you don't have any mass, you don't have any weight because you don't have any objects, right? We can also just come straight out and say, look, 1 kilogram weighs 10 newtons. How much would 2 kilograms weigh? 20 newtons. And if I have this guy right here, this is 0.4 kilograms. How much does this guy weigh?
4.
He weighs 4 newtons. See how that works?
Yep.
So mathematically, you say, oh, I'm just going to multiply it by 10, but it's not the same thing. Mass and weight are not the same thing. They are related through the slope. Is this linear?
Yeah.
All right. Madeline, what's a general equation for a linear? General equation for a linear graph.
My mind is blank, bro.
That's all right. I didn't mean to catch you off guard. Y equals mx plus b? Is that cool?
Yes.
So what's on the y-axis?
Wait.
So the weight of an object can be calculated if you know the slope, which is
10 newtons.
10 newtons per
Kilo.
kilogram times
Kilos.
the mass, and then plus 0. Okay? You guys got this? What's important about this, okay, is that this slope tells you how much an object is going to weigh. The slope tells you how much it's going to weigh, not how much it weighs, how much it's going to weigh. Like if I look over there, I'm looking over there, there's no objects over there. If I take an object over there, I'm going to feel like, bring it over here, yep, it definitely weighs something. But over there right now, there's no objects. But this 10 newtons per kilogram still applies. Still applies. If I take a 1 kilogram object over there, it's going to weigh 10 newtons. So what this slope is it's this fundamental concept, okay? And we have a name for it. We call it the, okay, this slope, this 10 newtons per kilogram is called the gravitational field strength. And on the surface of the Earth, it's equal to 10 newtons per kilogram of mass. If you go someplace else, guess what? It's different. If you go to the Mars, it's about 4 newtons per kilogram. If you go to the Moon, it's only 1.6 newtons per kilogram.
What's the planet with the most gravity?
So on Jupiter, it's 25 newtons per kilogram.
That's a lot.
Which means if you were holding a box on Earth that weighed 10 pounds, if you go to Jupiter, it feels like it weighs 25 pounds. But if you take that same box to the Moon, it only weighs 1.6 pounds.
That's pretty cool.
So like the spacesuits for the astronauts that they were wearing when they're bouncing around on the Moon, those things are like hundreds of pounds. You couldn't walk around on the Earth with them, but on the Moon, they bounce around no problem. Isn't that cool?
I didn't know that the spacesuits were that much.
They're pretty heavy. They're pretty heavy. Because think about it, they have to have all the radio technology, and they have to have all like the oxygen tanks and like the CO2 scrubbers, right? I mean, think about that. You ever gone scuba diving? How much does that tank weigh?
A lot.
A lot of weight.
Right? You see, I mean, they have to have one of those, right?
Under the water, it's fun.
That's the point, though.
Weightless.
That's why
That's the point.
That's why astronauts train underwater.
But the water's still on Earth, so it still has the same gravitational.
It is. That is 100% true. But when you go into water, water pushes things up.
Bounce even more.
My boats float. Anyway, this is called the gravitational field strength. It's super important. And we use the same little baby G. It's so important if you look up on the wall. If I ask you on, I don't know, maybe an assessment or a final exam, what's the value of the gravitational field strength near the surface of the Earth, what would you tell me?
10 newtons per kilo.
It's 10 newtons per kilogram. And if it said, which of the following is the best for every statement that describes the gravitational field strength? That's right. For every additional kilogram of mass, you get 10 additional newtons of weight.
I feel like you just gave us test answers.
He might have.
He said wink, wink.
Is that cool?
Yes.
All right. Functionally, what you need to be able to do is you need to be able to look at a problem, figure out what the mass of the object is, and then figure out how much it weighs. What's that? All right. Is that cool?
Yeah.
All right. So yesterday, hopefully you got from the sub something called Forces Homework 2. If you could bust out Forces Homework 2, yes? Did you print one out? It's not a problem that you didn't. It's not a problem that you didn't. Let me see if I can find a copy for you. No problem. I am happy to provide.
I got 44.
All right.
Not the most, this was the most music worksheet I've ever seen.
You guys are still like a day and a half behind.
I know, that's what yeah, that was, yeah, but I was just like,
Good. Well, let's find you. All right, you ready?
No, that's crazy. I didn't get that.